Here we have a parametric equation. That means we have x written in terms of t and y written in terms of t, but we don't have y in terms of x. And it's asking us for dy by dx. So using the chain rule, dy over dx will be dy over dt divided by dx over dt. So we can differentiate this with respect to t, and we can differentiate that with respect to t, and then we just need to divide one by the other. So dy by dt will be the derivative of 4 cosine squared. So again, you can use the chain rule, and that becomes 2 times 4 cosine t, and because it's cosine t rather than sine t, you need to use the chain rule and multiply by the derivative of cosine. So that 2 is that 2, and then you subtract 1 from the power, and then you multiply by the derivative of cosine. So if that was cosine t to the power 10, then dy by dt would be 10 cosine to the power 9t times sine t. So this is just application of the chain rule. Okay, so that's dy by dt. dx by dt is the derivative of that, and that's slightly easier. So dx by dt is simply 2 square root of 3 cosine 2t. So the derivative of 2t is 2, and the derivative of sine is cosine. Now you simply divide this by that. So we can write dy by dx is 4 cosine t sine t divided by root 3 cosine 2t. Now you could leave it like that, but nobody likes a surd in the denominator. So we try to rationalize the denominator. We try to get rid of the surd, and I think the question there wants it written in terms of tan 2t. So there's a little bit more manipulation we need to do. So let's recall an identity. It's a double angle identity. We know that sine 2x is 2 sine x times cosine x. Now, if you don't know that, it comes from the addition formula. So sine x plus y is sine x cosine y plus sine y cosine x. And if y happens to equal x, we can replace every y with an x. And then that becomes 2x, and that's equal to that, so we just have 2 sine cosine. Okay, so that's the reason why that's possible. Let me put that in grey, move that out of the way. So we can now use that information here, because that is essentially that, but instead of x, t. So we can now say dy by dx is 2 times sine 2x over root 3 cosine 2t. And if I multiply that by root 3 over root 3, I'm allowed to do that because that's just equal to 1. I can now replace sine over cosine with tan. Okay, so that's just tan. And the square root of 3 multiplied by square root of 3 just gives you 3. So your final answer will look something like 2 over 3 root 3 tan 2t. So that multiplied by that gives you 3. That multiplied by that gives you that. And sine over cosine gives you tan. So I think that's what they're asking for. So the question says it's k root 3 tan 2t. K is a constant to be determined. So it looks like this is our k. That's what it looks like. So I would say k equals 2/3. The question then goes on to ask for the equation of a tangent at the point where t equals pi over 3. So that's not too bad because we can replace t with pi over 3. I don't have a calculator on me, but I think we can still do this. So m for a tangent is equal to dy by dx at t equals pi over 3. So that looks like it's going to be 2 over 3 root 3 tan 6. Yeah, I'm not sure what that is, but I'll do it in terms of sine and cosine. So sine pi over 3 is root 3 over 2, and cosine root 3 is half. When you divide by half, you're multiplying by 2. So if I simplify that, that cancels with that. That goes with that. So root 3 times root 3 is 3. And the 3 will cancel with the 3. And I think you'll end up with 2. So assuming my calculations are correct, we have m equals 2. We still need to find x and y. Let's call it x1 and y1. So we'd get those from our question. So x is root 3 times sine 2t. 2 times pi over 3 is 2 pi over 3. And y is 4 cosine squared pi over 3. So I know that cosine squared pi over 3, I know cosine pi over 3 is half. Half squared is a quarter. Quarter times 4 is 1. I'm less certain about this. This 2 pi over 3 is 120 degrees. I think that's going to give me half. No, it isn't. Let's see. I don't have a calculator on me. So that's half. So if that's 90, that'll be 60. So yeah, sine 120 will probably be minus a half. So that'll be minus root 3 over 2. So now you know m, you know x1 and y1. you can write the equation of the tangent as y minus y1 equals mx minus x1, and then just put those numbers in. So that will go in there, that goes in there, and that goes in there. So you'll end up with y minus 1 equals 2x minus 3 over 2. If you multiply all by 2, or don't, just say y equals 2x plus root 3 plus 1. And there you have your equation of your tangent. So not too difficult. There's a slight issue here in that if you're unfamiliar with this identity, you might struggle to boil that down to that, or boil that down to that. But otherwise, it's fairly straightforward. Okay, I've just checked, and sine 2 pi over 3 is root 3 over 2. So I've changed that, and the equation now changes and becomes that. So that's your final answer.